So we're going to go ahead and continue with our look at inductive reasoning here. We've got predicting the next line in a sequence of computations. So we're off on the patterns now, looking at computation. So we have to look at what's happening from the left side to the right side. Notice here I've got 2 plus 4, and that's the same as multiplying 2 times 3. 2 plus 4 plus 6. Now I want to notice that I went from 4 to 6. I'm counting by 2s here. I'm counting the evens. So the last one's 2, 4, 6, 8. All right, well, how does the right side change? I go from 2 times 3 to 3 times 4 to 4 times 5. It looks like I'm taking the next bigger number and multiplying 3, and here 3 times 4, and then this number came down. And so now at 4 times 5, that means I'm probably going to be doing 5 times 6. And the left side would be 2 plus 4 plus 6 plus 8 plus 10. And if you add those, you should end up with 4 times 6, which is 30. And again, here this was 20, and so you add 10 to that, and you're going to get 30. So it does actually work. It does hold true. So let's take a look at this bottom pattern. Again, the first one is 1 plus 3, then 1 plus 3 plus 5, so we're counting the odds. 1 plus 3 plus 5 plus 7, so obviously the last one has to be 1 plus 3 plus 5 plus 7 plus 9. How does this work? 4, 9, 16. What's the pattern here? Well, these are the squares. This is 2 squared. This is 3 squared. This is 4 squared. The next one's got to be 5 squared, which is going to be 25. That's 5 squared. So the right side's probably a little bit harder to see than the left side, but if you see the pattern on the left, you can just add and get 25, and you would be in the same place. So let's take a look at more lists of computations. Notice the left side, we're adding 1 each time. We got 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. So the next one's got to be 1 plus 2 plus 3 plus 4 plus 5. Has to be, because we're just adding 1 each time. Now let's take a look. This one, each one's being divided by 2, so that part's not changing. Definitely over 2. So now how does it go on top? 2 times 3. 3 times 4. Notice this is the same. I went to the next bigger one. This is the same. This is the next bigger one. So that means this one's going to be the same. 5 times the next bigger number is 6. So that is what my pattern is going to be. All right, so here's kind of more what your homework looks like on this particular problem. We've got repeat the following procedure for the given numbers 1, 2, and 3, and 4. So it says to do that for each number. Basically, I do it for 1, I do it for 2, 3, and 4, and you're trying to figure out what's happening. So it says take your original number, you add 11, double the result, subtract 12, divide by 2, subtract the original. So it's a long process, and notice I broke the problem up here in a table for us so we can go step by step and follow the procedure. So if we make a nice chart, it keeps things organized. So I start with 1, add 11. Okay, so we're looking at 12. Double the result, 24. Subtract 12. I'm back down to 12 now. Divide by 2, that's 6. Subtract the original number. So if the original number was 1, I get 5. Okay, let's do it again for a new number. So our new number is 2. So I go 2, add 11, 13. Double the result, it's 26. Subtract 12. 14. Divide by 2, 7. Subtract the original number, 5. Well, that's interesting. 5 and 5. Let's do another one. I got 3. It says add 11, so I'm at 14. Double it, it's 28. Subtract 12, that's 16. Divide by 2, I'm at 8. Subtract the original number, 3, and I got 5. My guess is the last number is also going to be 5. So here I take 4, and I'm going to add 11 and get 15. And then I'm going to double the result and get 30. Subtract 12 at 18. Divide by 2 at 9. And then, of course, if I subtract 4, I get 5. So the key here is realizing that every time, no matter what you're going to do, you're going to get 5. So that's what it's looking for in the homework, is to recognize that pattern. So here we're going to try another trick. We're going to choose any, it's supposed to be any, natural number, multiply by 3, add 9, divide by 3, subtract the number you started with. So let's start with a natural number. Natural numbers are whole numbers that are like 1, 3, 5, 1, 2, 3, 4, 5, anything like that. So let's start with 7. So multiply by 3. Okay, 7 times 3 is 21. So it starts with 7, goes to 21. Sorry, 21. So I'm right here, I put 21 like this. Add 9 to it. Okay, I'm at 30. 30. Divide by 3, I get 10. Okay, subtract the number you started with, subtract 7, I end up with 3. Okay, so let's see if that's a pattern. So let's try a different number, like 10. Okay, if I try 10, I multiply by 3, I get 30. Add 9, and I get 39. Divide by 3, and I get 13. Subtract the number I started with 10. Subtract 10 from that, and I get 3. So this one's a number trick where it doesn't matter what number you start with, you always end up with 3. So it's just looking for, do you see the trick, how it works? All right. Good luck in your homework. Let me know if you have any questions. Email me with the Ask My Instructor feature of the lab.